Hello 5th grade, my name is Miss Martinez and this is our word problem for today. Aiden has a bag of candy. Some are spicy, sweet, and sour. 2/4 of the bag is sour. 1/3 of the bag is sweet. How much of the candy is sweet and sour? Okay, so what we're doing is we're going to add these fractions, okay? So we have 2/4 is sour and 1/3 is sweet. So we're gonna add these, okay? And so when we're doing fractions, the bottom is called the denominator. So it's the parts of the whole, the parts that the whole is divided into. And the top portion is called the numerator, which is how many parts we have. And some common misconceptions that we have with fractions is that sometimes we may think that just because the denominators, for instance, just because one is smaller than the other, that we may automatically assume that the 1/3 would be bigger than the 4, just looking at the denominators. So we would think that this is a smaller piece of the 4. So for example, 1/4 and 1/3, they have automatically a misconception can be that the 3 is smaller than the 4, but that is not true, because in this case the 1/3 is actually bigger than the 1/4. Okay, so that was just a misconception for you to think about, and just to help you so you won't get confused. Okay, so let's look at our question again. 2/4 plus 1/3, so that means we are adding them. So this is the whole. This means that this circle is how many candy we have in the whole bag. So the spicy, the sweet, and the sour. But we're not asked for the spicy. We're just asked for the sweet and the sour. Okay, so we have 2/4 plus 1/3. So first what I want to do is let's trace this really quickly. Okay, just to see, this is our exact copy. Okay, so we're doing 2/4. So 2/4 would look like this, correct? Okay, and we can actually draw a line as well to show this. Okay, so this is 2/4, and then we have 1/3. So our 1/3 is right here. We can trace this as well to show this is 1/3. Oops. This is 1/3, 2/4. Okay. So in math, we can't add fractions that have different denominators. So we have 2/4 and 1/3. That's not going to work. We can only add when the denominators are the same. So let's just do this real quick. So in 2/4, some of the factors, when we skip count, we have 4, 8, 12, and 16. And in 3, we have 3, 6, 9, and 12. Oh, we already got one. We have 12. So we know that our common multiple in this, our common denominator, is 12, okay? So we know that we're going to use 12 in order to add these fractions up. So let's make another copy of this, because we have to remember that this is our whole. Okay, so this is the whole. So we are doing, remember, 2/4 plus 1/3. Okay, so in order to know how much 12s we need in the 2/4, we can simply do this. We have our 12s because we know 12 is what's common in both denominators. Okay, let's try to align them, because in math, we know we have to be very precise. And we're going to find out something else after we do this. Okay, so we saw this was 2/4, correct? So now we know that Let's count this up. 1, 2, 3, 4, 5, 6. There's 6 12s. So this actually, 2/4 is actually equivalent to, how many did we say? 1, 2, 3, 4, 5, 6. 6/12. So these are equivalent, okay? So now let's do the 1/3, okay? So we can see how many we need to add them into our final circle. Okay, so we have 1, 2, 3, 4. So the 1/3 is equivalent to 4 12s. Okay, so let's move this into our final circle. So we know that this was equivalent to 6/12 and this was equivalent to 4/12. Okay, so let's add that into our final circle, okay? So we can do we would add them all up together. So remember, this is the area model. So this is the area that the pieces are taking up in the fraction, okay? So let's count these all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10/12. But we can't leave that like that. We know in the 5th grade that we know how to simplify. So 10 divided by 12. We know that those both can be divided by 2. So we divide them by 2. And we know that that would be 5 and that this would be 6. Because 5 times 2 equals 10. 6 times 2 is 12. So we got 5/6. So in order to check our work, let's actually get these as well. And this should fit exactly on top. So that's 1, 6. This is 2, 6. 3, 4, and 5. And it aligns perfectly. So we know that when we added 2/4 plus 1/3 of the candy, we had 5/6. So we learned how to add fractions with that the denominators are not the same, okay? So now let's do this with the linear model, okay? So we can just flip the back page, okay? So now we're not going to use these circles. So our problem is still the same. We have 2/4 plus the 1/3, okay? This one is our whole, okay? And we learned what whole meant. And, okay, let's do this. Okay, so we have 2/4 and 1/3. So let's get 1, 2 or 2/4. We can just move it up here. And our 1/3. So we know we cannot, what we learned is we cannot add when our denominators are different. Correct? So we learned that the common denominator in this, the number was 12, right? So let's use our little mini 12s and see how many we get for 1/4 first. And it should be the same as we got last time. And remember guys, we learned this in 3rd grade. Whenever we're doing this, we're finding what the equivalent, right, is of 2/4. With the 12s, we are decomposing, breaking down this number, okay? So we saw 2/4, it can be broken down into 1, 2, 3, 4, 5, 6, 6/12. So that is correct. Then the 1/3 can be broken down, into 1, 2, 3, and 4. Okay. So this was 1, 2, 3, 4. When broken down, decompose. 4/12. Okay. So we can automatically, now that our denominators are the same, we can just add straight across. So we know that the 12 would remain the same because this is the parts of the whole, correct? So we know that this space right here is the part of the spicy, but that's not what we're looking for, right? Okay, so then we would do 6 plus 4 is 10, okay? But we know we always have to show our work. So what we would do is, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. And we know that we cannot leave that there. We have to simplify by 2, right? This would be 5/6. So we got the same exact number. So that's how we learned. So today we learned how to add fractions with different denominators with the area model and with the linear model. Okay, guys? So we always have to remember to find what's common, and then that's when we can add them up, okay? So thank you very much.